Hello, welcome to another episode from Spiral Physics Education. So in this session we're going to be looking at energy resources, but starting with electricity as being the main focus of this, because as a modern world we run on electricity. It's one of the most important sources of energy, but in fact it's a secondary source of energy, so we're going to be looking at what that means. We're going to be looking into renewable and non-renewable energy sources, and some examples and pros and cons of a variety of different energy resources. So what is it you need to know? We need to know about different types of energy stores and transfers, the principle of conservation of energy, efficiency, the definition of work, energy and power. And if you're unsure about any of those, don't forget to check out some of the videos on the channel to help you to get up to speed before continuing with this episode. So energy resources, as I mentioned, that electricity is often referred to as a secondary energy source, and what that means is that it's not readily available out there. You can't go out there and dig it up and collect it. It's like coal is a primary source of energy. Electricity, you need to use something else to generate it. And those primary sources of energy usually come into two groups: renewable and non-renewable energy sources, and we use those to produce electricity, and therefore electricity is referred to as a secondary energy source. So let's look at non-renewable energy resources. Well, these are non-renewable because one day they will run out, and that this means that they're finite energy resource, and one day we won't have them anymore, and that's because we are using them up faster than we can replenish them, and then that's non-renewable. And all fossil fuels are non-renewable energy resources, or examples of non-renewable energy resources, and that's because they take hundreds of millions of years to be produced, but we use them up far quicker than that. And these include coal, oil, and gas, or natural gas. Nuclear energy is another example of a non-renewable energy source, but it's not a fossil fuel. It's energy that's released from the nucleus, and elements like uranium are mined from the ground, and they're used in power stations, a little bit like this, under a process called nuclear fission. So they will run out one day, but it's not an example of a fossil fuel. Renewable energy sources, one day they're not going to run out, and therefore they're an infinite energy resource. And what we can say about those is that anything that we use up, their resources are replenished quickly, or the rate at which we're using them is less than the rate at which they're replenished. So we can manage some energy resources for them to be renewable if we take care with the replenishing rate. So examples of those, we have solar cells, wind power, and hydroelectric power. We've got wave power, biomass, geothermal, and tidal. All of those are examples of renewable energy resources. So what we're going to do now is look at some pros and cons. And this is very important for getting good scores in exams, because it's very, very common. Sometimes they might ask you to compare the pros and cons for different energy resources. So let's start with coal. One of the main pros for coal is that it's reliable, and that means that if you burn it, you're going to get electricity out of it. It doesn't depend on anything else. So all the fossil fuels are reliable that way. Relatively cheap, easy to burn, easy and cheap to transport, and you get a relatively large amount of energy out of coal when you burn it. And apparently the United States has about 400 years supply of coal, and I guess for the United States then that means that it's abundant. We used to have lots of coal mines in the UK. Not so much these days. When I was at school in the 80s, it was suggested there'll be 30 years worth of coal left. We're beyond 30 years later now, and apparently we still have an abundant supply, particularly if you live in America. In terms of cons, well, they're non-renewable. They're going to run out one day. They release carbon dioxide, which is a greenhouse gas. They release sulfur dioxide, which can cause acid rain. But be very careful if you overgeneralize your answer there and you say something like polluting gases. You've got to give examples. So you've got to say carbon dioxide, which is a greenhouse gas, or sulfur dioxide, which produces acid rain. Don't just say produces polluting gases. And coal mining is also destructive to the environment because you have to mine it and dig it out of the ground. So let's have a look at oil and compare that to coal. Well, they're very, very similar. All of the pros are identical. Cons, identical as well, apart from spillages. So you can talk about oil being spilt, that pollutes the environment, kills animals, etc. So that's one of the differences between coal and oil. So if we look at gas, very similar again, except it's the cleanest of the lot. And in terms of supply, apparently there's a lot of gas out there because we're discovering more and more sources of gas. In terms of cons, it's also non-renewable, carbon dioxide. So nuclear is, remember, it's not a fossil fuel, so it's not burnt, although it's still very, very reliable. And because it's not burnt, there's no carbon dioxide or sulfur dioxide or any polluting gases produced. So it's relatively clean compared to fossil fuels that way. And therefore, it's thought that along with the low running costs and the large amount of energy produced compared to fossil fuels per kilogram, it's thought that this is the source of energy that is going to be much cleaner for the planet, really because it's reliable and it produces no carbon dioxide or sulfur dioxide. It's non-renewable though, so it's not going to be around forever. And one of the horrible things about it is it produces waste products that are radioactive, and it's going to be radioactive for millions of years. And that means you've got to manage those. So it's not only cheap to do that, but it's not nice to produce those radioactive waste products. They're very, very expensive to build, extremely expensive to do the opposite of building, which we call decommissioning, and that's the breaking down of the building and all the components of the building, making sure you're removing all the radioactive sources, the leftover sources and waste material. That's extremely expensive. So expensive to build, expensive to decommission, but in the middle there are low running costs. So ultimately it's quite expensive to generate electricity from nuclear power. So let's have a look at solar cells. Well, the main thing is that it's renewable. We're not burning anything, so there's no carbon dioxide or sulfur dioxide or other polluting gases produced. Once you've built it, there are low running costs. So those are the main advantages there. Disadvantages, it's not reliable. In the UK, we have at best 12 hours of sunlight a day. Today it's cloudy, it's winter, so hardly any hours of sunlight today. So it's not the most reliable source of energy, particularly in the UK. And it requires a large area of land to generate a decent amount of energy out of. So you might see those out in the countryside where farmland has got lots and lots of solar cells placed all over it. And I guess you could say that some people think they're ugly to look at, but that's subjective. And the main thing is that they're so expensive to build initially, but once you build them, they've got low running costs. They don't really need anything after that. So what about wind power then? Well, very similar to solar, it's renewable. We're not burning anything, so there's no carbon dioxide or sulfur dioxide. There's also low running costs. So identical pros there. Against, it's unreliable, it's not always windy. Apparently there's a danger to migrating birds, so there are some places in Scotland that would have been ideal for wind power, but it was decided that we weren't going to build the wind farm there because of migrating birds, that it could kill them. Similar to solar panels, it requires a massive area of land to produce a wind farm. And similar to solar cells, some people think they're ugly to look at. Personally, I think they look quite nice to look at, but I certainly wouldn't want one in my back garden. And again, initial costs are very expensive, especially to get the materials and to put them together. And also, they're very, very noisy. So if you live near a wind farm, you would hear that a lot. And you've got to put them in windy places, and there's not always windy places available. So hydroelectric power, well, again, you're going to see that some of these are very, very, very common. The thing about hydroelectric is, though, that it's very reliable. If you have water running through a generator, it will produce electricity. So hydroelectric power is reliable. And you could also argue that it gives opportunities for water sport activities as well. So the cons damages the environment due to flooding. That's a major one. You can't build one anywhere. It requires some geographical favourable surroundings. So although it's reliable, you've got to have a good place to build them. Migrating fish are affected by the design of a hydroelectric power station. And again, some people think they're ugly to look at. Personally, I think they're quite amazing to look at. Dams and things like that, I'm interested in them, but again, I wouldn't necessarily want to live right next door to one. And like many of these things, the initial cost is expensive due to the amount of materials used. So Tidal, well, renewable, doesn't burn anything. It's technically reliable. It's technically reliable because there's only 2 tides a day. Although you have to have very specific geographical sites required. So for example, the Severn Estuary, that's probably the only place in the UK where we could build a tidal barrage. Although it's reliable, there are 2 tides a day. All that goes against it is that there are only 2 tides today. So if you wanted electricity in between those 2 tides, you couldn't get it from tidal power. And like so many of these things, they're expensive to build. And that some designs cause environmental damage to land, similar to hydroelectric dams, so it can cause flooding. Geothermal. These are going to be very common again. So geothermal, it's renewable, it's not burning anything. And geothermal is reliable. You can get energy from it all the time. And you don't actually need a large building on the surface of the ground. Most of it happens underground. So it's absolutely fine to use small areas like that for geothermal. Against it, well, you've got to have some a land where you've got geothermal activity, like Iceland. Don't get a great deal of geothermal activity in the UK, for example, so it's not great for us. Biomass, renewable. Although when biomass, if you're burning something, you're still releasing carbon dioxide. That carbon dioxide is young. For example, if you decide that you're going to burn some wood, for example, that wood might only be 10 years old. So you're replacing carbon dioxide into the carbon dioxide chain that was there 10 years ago. The problem is with fossil fuels is you're releasing carbon dioxide that was in the atmosphere from millions or thousands of millions of years ago, and that's the bad aspect of carbon dioxide. when you breathe out, you release carbon dioxide, but it's very, very young carbon dioxide. Biomass is also reliable. If you burn it or release the carbon dioxide from it, you're going to produce energy very, very reliably. And burning the waste reduces waste on landfill sites, which we've got lots and lots of these days. Going against biomass, well, it does produce polluting gases. So anytime you burn, you are still releasing carbon dioxide. You release carbon monoxide because it's reduced burning in oxygen. You're releasing nitrogen oxides, which could increase acid rain and smog. Relatively expensive to maintain too. So finally, for wave power, well, it's renewable. It's never going to run out. There's an abundant supply of water for the waves and wind to obviously produce the waves on the planet. We're not burning anything, so there's no carbon dioxide, which is a greenhouse gas, and there's no sulfur dioxide, so it doesn't produce any acid rain. So those are the main pros for wind power. The only problem is it's unreliable. There's the waves are generated only when it's windy and where you've got water, obviously. So therefore, it's you might not have any water. Not very good for you then. And even if you have the water, it might not always be windy. Obviously, just geographically dependent. So we're very, very lucky to have the opportunity to have lots of wave power, but that doesn't mean everyone's going to benefit from wave power. However, if you do build something that's going to generate electricity from waves, it's going to be disruptive to shipping, or it can be. In rough weather, weirdly, lots and lots of waves can actually produce performance problems, and it reduces the amount of energy released. And again, some people think that they look ugly on the water. Other people might think they look fascinating. So hopefully you found that useful. Don't forget to subscribe to the channel, and I'll see you next time on Spiral Physics Education. Goodbye.